So next topic is matrix representation of graphs. Graphs you can represent using the sets and the function, the vertex set, the edge set, and the incidence function you can give. That way you can represent a graph, or as a diagram you can represent a graph, or now using matrices also you can represent a graph. The two types of matrices that represents a graph we have, which is adjacency matrix and incidence matrix. In adjacency matrix, the information regarding which pair of vertices are adjacent, that is being recorded. So suppose you have a graph like this, v1, v2, v3, v4 are the vertices. In that case, the adjacency matrix corresponding to that graph is a matrix in which the rows are represented by the vertices v1, v2, v3, v4, and the columns are also represented by the vertices v1, v2, v3, v4. Now which pair of vertices are adjacent, that information we are recording here. So in the given graph, v1 is not adjacent to v1, therefore against the row and column for v1 we will enter 0. If v1 was adjacent to v1, which means at v1 we had a loop, in that case we will enter that entry as 1, right? So which is basically the diagonal entry, right? So we are having the ith row and ith column are represented by the same vertex. So a vertex is having a loop at it. In that case, the corresponding entry will be coming in the diagonal only because of this. Okay, so yeah, so we don't have a loop there, therefore the entry is 0. At v1 you don't have a loop, therefore it is 0. At any of the vertex v1, v2, v3, v4 we don't have a loop, therefore all the diagonal entries are zeros. Right, now it's an undirected graph. So if v1 is adjacent to v2, in that case we will represent, there is only one edge from v1 to v2, that will represent as 1 against row for v1 and column for v2. v1 has one edge with v2, so that will represent as against the row for v1 and column for v2 will enter 1. So the same edge is there from v2 to v1, therefore against the row for v2 and column for v1 also we will have the same entry. So basically, generally if you have ith row vertex is adjacent to jth column vertex, in that case we will be having the entry as 1. So since it's an undirected graph, the edge from vi to vj will be there from vj to va also, which means the jth row vertex will be adjacent to ith column vertex also, which means ijth entry and jith entry in this matrix is going to be same. This matrix is going to be symmetric. The rows, if you take the transpose, you will be getting the columns. Therefore this matrix, it's on transpose, it's a symmetric matrix that is going to be generated with this idea. So if it is a symbol graph, the entries will be only zeros and ones, right? Symbol graph doesn't have a loop, therefore all the diagonal entries will be zeros. Now if a vertex is adjacent to the another vertex, the row for that vertex and column for that vertex, the other vertex, the corresponding entry there, right? If vi is adjacent to vj, against the row for vi and column for vj, the cell entry will be 1, otherwise it will be 0. So this way we are forming the matrix. Okay, this is called an adjacency matrix of a symbol graph. Now if it is multi-graph where you have parallel edges, how many edges are present? Say v1 to v2 you have 2 edges. So previously v1 to v2 only one edge was there, so we were representing 1 there. If you have 2 edges, parallel edges are there, the entry will change as 2. Right? Now suppose you have a loop at v3, we'll be having the diagonal entry for v3, it will be 1 there. Right? If you have 2 loops there, the entry will be 2. And this way we'll make the entries of in the cells, right? In the cells we will make these entries. So this is how we form a adjacency matrix for a undirected graph. We see that this method gives you a symmetric matrix for an undirected graph. Not only that, we have several other properties. So if it is a directed graph, the change is that if the direction is v1 to v2, then the row for v1 and column for v2 has entry 1. If the edge from v2 to v1, the other direction, if it is not there, then corresponding entry for v2 v1, v2 row v1 column will be 0. right? So which means for directed graphs it need not be a symmetric matrix. That adjacency matrix won't be a symmetric matrix. So this matrix is square that we first identify because the number of rows and number of columns are exactly the same, right? It is the number of vertices of the graph. Now if you sum the entries in a row, you will get basically the degree of the vertex. So the entries, how many positive entries are there against the row for v1, that many edges v1 has, therefore its degree will be that sum itself. So the sum of entries in any row will give you the degree of the corresponding vertex. Also the sum of entries in a column will give you for which column this column is represented by which vertex, its degree will be getting. Now if you have the loops there, then you have to multiply, while adding these entries you have to multiply the diagonal entry with 2. So a loop contribute 2 to the degree. So to balance that, the diagonal entries in adjacency matrix, once you sum it to once you sum the row entries or column entries to find the degree, if you have loop, the diagonal entries can be non-zero, and in that case if the diagonal entry is non-zero, you have to multiply, while calculating the degree you have to multiply the diagonal entry with 2 and rest of the entries as it is to add and get the degree, right? So if at v1 you have a loop, in that case you will be having 1 here, and while calculating the degree using the adjacency matrix, you will multiply the diagonal entry position with 2 and remaining entries you will add. So 2 plus 1 plus 1 plus 1, that will be 4. And at v1 we have 3 normal edges and 1 loop. A loop contributes 2 to the degree, so 2 plus 3 5. So you are having 2 plus 3 5 itself here as the sum also here, right? So this 1 will be multiplied, diagonal entry 1 will be multiplied by 2. Okay, so yeah, so this is the idea of a adjacency matrix. The entries for a multi-graph or a pseudograph, it can be more than one also. Okay, so this is a pseudograph we are having. The corresponding adjacency matrix is at A, so the vertices are ABCD, so ABCD rows and columns are there. So against row for A and column for A, you will have 1 because at A you have a loop. A to B you have 2 edges, therefore row for A and column for B will have the numbers 2. Row for B and column for A will also have the same number because it's an undirected graph. An edge from A to B is also an edge from B to A. So this fashion you can enter the values in the adjacency matrix, you will be forming such an adjacency matrix, right? So if it's a directed graph, as I said, you have an edge from A to B, row for A and column for B will have entry 1, but there is the other direction. If it is not there, B to A, the edge is not there, in that case row for B and column for A, that entry will be 0. So that this is not going to be a symmetric matrix. So 1 2 position, you are first row second column is 1, second row first column is 0. So it's not, Aij is not Aji. This is not going to be a symmetric matrix. For a symmetric matrix, ijth entry and jth entry will be same. So directed graph, its adjacency matrix need not be symmetric. Now we can form another matrix called incidence matrix, which gives you which edges in the graph are incident on which vertices. So we'll label the vertices and edges. So take this particular graph, we are having 4 vertices and 5 edges. So you'll form a matrix where the rows are represented by the vertices of the graph, the columns are represented by the edges of the graph, and the entries in the graph is each edge is incident on which pair of vertices. Against that vertices you will give entry 1. So E1 is adjacent to V1 and V2. So against V1 and V2 rows we will be giving 1 for the column of E1. Remaining entries will be 0. For E2 it is adjacent, sorry, it is incident on V2 and V3. It's an edge between V2 and V3, so it's an incident on V2 and V3. So against the row for V2 and column for V3 in E2 column you will have 1. Other places it will be zeros. So E3, V4, V3 will be 1, V4 and V3 will be 1, remaining will be 0. E4, V1 and V4 will will be 1, remaining will be 0. E5, E5 is between V1 and V3, so V1, V3 rows, the entries will be 1, remaining will be 0. Such fashion we are forming a matrix, that is your incidence matrix. Okay. Now if loops are there, the loops, for a loop, both the vertices are same, therefore these so you'll be entering for corresponding vertex where the loop is there, that edge corresponding to that edge you will give 2 as the entry. Suppose you had a loop at say V1 and that loop is the edge E6, then you will have one more column here E6, and against V2 you will enter both the ones, you will be giving 2, and remaining entries will be all zeros. Okay, so what are the properties you see in the incidence matrix? Any column sum is 2. It basically represents every edge has 2 end vertices. For every edge, that 2 against that end vertices only, you are giving 1, right? If it is a loop, that 2 end vertices are the same, therefore we are giving 2. If parallel edges are there, then we will be having one more edge, that's it, right? So yeah, so now if you sum the entries in any row or column, you will be getting the degree of the vertex. So how many edges are incident on a vertex is given to you by the sum of entries in any row, right? Corresponding vertex, what is the degree you will be getting. So that's the idea. So incidence matrix need not be symmetric because number of rows and number of columns has to be same for a square matrix. So it need not be a square matrix, the incidence matrix. You need not have number of vertices same as number of edges. So in general, incidence matrix is a rectangular matrix. Okay, and the entries are zeros and ones, and 2 can be there. The maximum value is 2, right? Other than that, we won't be having. 3 is not possible there. So every edge is having exactly 2 end vertices. So if that 2 end vertices are same, then the entry is 2, which is the case of a loop. Otherwise, the entries are zeros and ones only. Okay. So this is the incidence matrix idea. So you have several examples here. You are given the incidence matrix of the graph. You are asked to write the. Sorry, you are given the graph and you are asked to write the incidence matrix. So how many vertices are there? V1, V2, V3. So it's a matrix with 3 rows. Okay. V1, V2, V3, and the edges, how many are there? 5 are there. E1, E2, E3, E4, E5. If it's not already labeled, you can label them and use that labeling. Okay, so E1 is a loop. It is a loop at V1, therefore the entry will be 2. The remaining entries in this column for E1 is 0. E2, it is from V1 to V2. So V1 and V2 entries in the column E2 will be 1, other places it will be 0. E3 again from V1 to V2, so 1, 1, 0. E4 from V2 to V3, so 0, 1, 1. E5 is a loop at V3, therefore 2 here and 0, 0. This is the corresponding incidence matrix. Now for this particular matrix, how many vertices are there? V1, V2, V3, V4, V5. So it's a 5-row matrix. V1, V2, V3, V4, V5. How many edges are there? E1, E2, E3, E4, E5, E6. 6 edges are there. So it's a 5 by 6 matrix you have to form. E1, E2, E3, E4, E5, E6. Now check which edges are between which pair of edges. There are no loops, therefore the entry 2 won't be there here. So you are having E1 is between V1 and V4, so V1, V4, that rows it will be 1, other place it will be zeros, 3 other zeros, right? So E2 is between V1 and V5, so V1, V5 entries will be 1, remaining places it will be 0. E3 between V1, so yeah, that is E3 actually, E3 is, E3 is between V4 and V2. E3 is between V4 and V2, so 1 against V4, V2, remaining places it is 0. E4, it is between V2, V5, so V2, V5 entries are 1, other place it is 0. E5 is from V2 to V3, therefore that V2, V3 entries are 1, remaining is 0, are 0. E6, V5 to V3. So V3 to V5. So V1, V2 are zeros, V3 it is 1, E6, V3 to V5. So V4 it is 0, V5 it is 1. So this is the corresponding incidence matrix. Now you are given the graph and you want to, for the second part, you want to find the adjacency matrix. So what will be it? Here, for vertices are there, A, B, C, D you have labeled. So A, B, C, D rows and A, B, C, D columns you will be having. And A has a loop at it. So therefore, there is a diagonal entry for A. And B, for B also loop is there, diagonal entry is there 1. One loop is there, therefore 1 is the entry. If 2 loops are there, 2 will be the entry. So similarly, C has a loop, D has a loop. The diagonal entries are this. Is an undirected graph also. Therefore, it is going to be symmetric matrix that you are going to get. So you just have to identify what are the entries in the upper triangular part of the diagonal, or upper triangular part only you have to identify. The lower triangular will be the reflection of that. Write the same entries as transpose, it will be repeating here. So what are the entries in the first row for A? A is adjacent with A to B, there is no edge, so therefore it will be 0 there. A to C, you have parallel edges, 2 edges, so 2 is the entry, 2 edges are there. A to D, you have 1 edge, so therefore it is 1 there. Now the 0 to 1, as for the column for A also will be having the same entries in the column, so 1 0 2 1. It's a symmetric matrix you are going to get. Now for B, A and B adjacency we have already checked. For C, B to C, you have 1 edge, so therefore it is 1 there. B to C we have an edge. B to D we have 2 edges, so it is 2 there. Now the same entries will be there for C to B and T to B. So the same row you will give us the second column. Second row is same as second column. Now for C to D you don't have an edge, so it's 0. So D to C also you don't have an edge. So correspondingly this is the adjacency matrix you are getting. Now for the next example, you are having A, B, C, D, E, 5 vertices are there. So it's a 5 by 5 square matrix you will be getting. A, B, C, D, E. So there are no loops, the diagonal entries are all zeros. Okay. Now it's undirected, so symmetric matrix you are going to get. A to B, 1 edge, so there are no parallel edges also you see, so all the entries are going to be zeros and ones. A to B you have an edge, A to C you don't have, to D also you don't have. From A you have only edges to B and T, so we will be having the same row coming as column also, 1 0 0 1. Now B is adjacent to C. Yes, it is not adjacent to D, it is adjacent to E. So 1 0 1 0 1 is the second column, it is the second row, it is the second column also, 1 0 1 0 1. Now C, is it adjacent to D is what you have to check. It is, so 1 is the entry. C to E there is no edge, so 0, so 1 0. Now D, is it adjacent to E? Yes, so the adjacency is 1 there, and it is 1 here. So this is the corresponding adjacency matrices. Now given the, so diagram representation of graph will give you the matrix representation of graphs, right? Incidence and adjacency matrix. Now if you are given the adjacency or incidence matrix, you can form the graph as a diagram also. So you are given, draw the graphs. So the question is, draw the graphs represented by the following adjacency matrices. So this is an adjacency matrix, a square matrix first of all, then only it can be adjacency matrix. Now for this adjacency matrix, what will be the graph? We can label the rows and columns with same ordering, V1, V2, V3, V4. 4 vertices are, 4 rows are there, V1, V2, V3, V4. So 4 vertices will be there in the corresponding graph. First, draw the nodes of this graph, V1, V2, V3, V4. Now all the diagonal entries are 0, so there are no loops at any vertex. Now v1 row you are having 3 ones, it is adjacent to all the remaining vertices. So v2, v3, v4, v1 is adjacent to. v2 you have 2 ones, it is adjacent to v1, that is already recorded because v1 to v2 edge if you have given, v2 to v1. So this is a symmetric matrix. If you identify, then it is going to be undirected graphs adjacency matrix only. So it is a symmetric matrix. The row 1 is same as column 1, row 2 is same as column 2, row 3 is same as column 3, and row 4 is same as column 4. This is a direct undirected graphs adjacency matrix. So v1 to v2 information once you have recorded, v2 to v1 it is the same, so you only have to check at the upper diagonal in this case. Anyhow, let's repeat for the lower triangular part also. You check the upper triangular only. If you do, you will be getting it. And I mean the upper triangular, not diagonal. For the upper triangular entries only, you have to actually draw the edges in a undirected graphs adjacency matrix, because the lower triangular part is actually a repetition of that. If it is directed, then it is separate. You have to do it separately. Now what you have, v2 to v1 you have an edge that is already represented. v2 there is no loop. v2 to v3 you have an edge. v2 to v4 there is no edge. Okay. v3 to v1 that edge is already given. v3 to v2 edge is already given. v3 there is no loop at it. v3 to v4 you don't have an edge, 0. Now at v4 you have only one edge, which is to v1. All the remaining are 0. So this is the corresponding graph you will be getting. Now for the second adjacency matrix, again you will label the vertices as v1, v2, v3, v4. For the rows and columns you will give the same ordering for vertices and form the, so 4 vertices are there, v1, v2, v3, v4. Now there are loops here. For the diagonal entry for v1 it is 1, therefore there is a loop at v1. There is a loop at v3 also, because that diagonal entry is also 1, right? Now 2 is the entry for v1, v2. v1, v2 and v2, v1, the same entry is there, therefore you have parallel edges from v1 to v2. v1 to v4 you have an edge, v1 to v3 there is no. Now v2, 2 parallel edges to v1, 3 parallel edges to v3, there is no loop at v2. v4 there is no edge from v2. v3, 3 parallel edges to v2, no edge to v1, one edge, one loop at v1, and one loop at v3, and because you have this one entry, and v4 to v4 you have an edge. So this is the corresponding graph you will be getting. So yeah, v4 column also we have to check. So for v4 you are having 1 0 1 0, v1 edge is already given, v2 edge there is no v2 edge, v3 edge we have already given, v4 entry is 0. This is the corresponding adjacency matrix you will be getting. Now the last one, 0 0 1 1, 0 0 1 0. So second row is 0 0 1 0, second column is 0 0 1 1. So this adjacency matrix is not for undirected graph, it's a directed graph. So you label the edges, label the vertices v1, v2, v3, v4, v1, v2, v3, v4. What will be the corresponding graph now? You draw the nodes v1, v2, v3, v4. v1, so it's a directed graphs adjacency matrix because it is not symmetric, right? By identifying that you can say that. So you have second row and second column are not same, therefore this matrix is not symmetric. You are having 2 4 entries not same as 4 2th entry, 4 2 position, so they are different, therefore it's not a symmetric matrix, and hence it is this adjacency matrix. It's not for a undirected graph, it's for a directed graph. So for v1 column I am having 1 at v3 and v4. So v1 to v3 this direction you have an edge, v1 to v4 this direction you have an edge. For v2 row we have v3 column is 1, so v2 to v3 you have a directed edge. v3 row we are having v1, v2 and v4 edges are there. For v3, v1 there is an edge, so this direction there is an edge, then v2 V2 you have an edge, V3 to V2 you have an edge, this direction. Then V3 to V4 you have an edge. For V4 you are having to V1 there is an edge, V2 there is an edge, V3 there is an edge. Okay, so there are no loops here. Okay, so this is the corresponding graph you will be getting. If both direction edges are there, you can just represent it in the same line itself. You can give both directions, and if the direction is not specified, it means both direction edges there. Okay, so that way you can give it.